Hello students, I Devang Prajapati from उपनिषद साइंस एकेडमी। आज बच्चों हम द वर्ल्ड ऑफ पॉलीमर की दुनिया में जाने वाले हैं। ठीक है, स्ट्रोक नंबर 2 है। ओके, ये जो आज का पूरा सेशन है दैट विल बी फ्रॉम द एनसीईआरटी पेज नंबर ऑफ 12th स्टैंडर्ड 427 to 429। ओके, तो लेट्स स्टार्ट। So first we'll do the classification based on the molecular forces. Okay, so a large number of the polymer applications in the different fields depend on their unique mechanical properties like tensile strength, elasticity, toughness, etc. Okay, then these mechanical properties are governed by intermolecular forces, for example van der Waals forces and hydrogen bonds present in the polymer. Then these forces also behind the polymer chains. Okay, under this category the polymers are classified into the following four subgroups. Okay, on the basis of their magnitude of the intermolecular forces present in them. Okay, based on the intermolecular forces it has been classified in four subgroups. Okay, the first one, that is the elastomers. These are rubber like solids with the elastic properties. In these elastomeric polymers, the polymer chains are held together by the weakest intermolecular forces. Okay, these weak bind forces permit the polymer to be stretched. Then a few cross links are introduced in between the chains. Okay, which help the polymer to retract to its original position after the force is released as in vulcanized rubber. ओके, बिकॉज ऑफ द क्रॉस लिंकिंग की वजह से वापिस वो अपने शेप में आने जाने वाले हैं. ठीक है, आ जाने वाले हैं. सो एंड फ्यू एग्जांपल्स ऑफ द इलास्टोमर्स आर ब्यूनायस, ब्यूनायन एंड नियोप्रिन. ठीक है, देन this is the neoprene monomer, how it look like. Okay, CH2 single bond CCl, double bond CH, single bond CH2. Okay, n times. Okay, the two most essential features of the elastomers are viscosity and elasticity. Okay, then the second is fibers. Fibers are the thread forming solids which possess the high tensile strength and high modulus. Okay, then these characteristics can be attributed to the strong intermolecular forces like hydrogen bonding. These strong forces also lead to the close packing of chains and thus the impact thus crystalline in nature. Okay, because of this they will become the crystalline in nature. Okay, then few examples are nylon 66 and terylene. Okay, nylon 6 is having the polyamide in nature. Okay, terylene is having the polyester in nature. Then thermoplastic polymers. So these are the linear or slightly branched long chain molecules. Okay, capable of repeatedly softening on heating and hardening on cooling. So these polymers possess the intermolecular forces of attraction intermediate between the elastomer and fibers. So between the properties will be between the elastomer and the fibers. Okay, then few examples are polythene, polystyrene and polyvinyls. Then thermosetting polymers. These polymers are cross-linked or heavily branched molecules which on heating undergo extensive cross-linking in the modulus and again become the infusible. Okay, so this cannot be reused, means you cannot utilize the thermosetting plastic again and again. Okay, some common examples are bakelite, urea formaldehyde, resins. Then classification based on growth of polymerization. Okay, that is 2 addition and condensation, or you can also call it as a chain growth polymers or step growth polymerization. Okay, then types of polymerization reaction. Okay, broadly it has been divided in two categories. Okay, one is addition or chain growth polymerization and condensation or step growth polymerization. Okay, so let's start addition or chain growth polymerization. In this type of polymerization, the molecules of the same monomer or different monomers add together on large scale to form the polymer. The monomers used are unsaturated. इसमें unsaturation मिलने वाले, डबल बॉन्ड और ट्रिपल बॉन्ड. एग्जाम्पल दिए गए alkenes and alkynes. Okay, these mode of polymerization leading to the increased chain length or chain growth. That's why the name has been given, that is the chain growth polymerization. Okay, and here these will be taking place by the free radicals or the ionic species. Okay, the most common will be based on the free radicals. Okay, so let's start the free radical mechanism. Okay, a variety of alkenes or dienes and their derivatives are polymerized in the presence of free radical generating initiator catalysts like benzoyl peroxide, acetyl peroxide or tertiary butyl peroxide. Here we are taking the example of benzoyl peroxide. Okay, C6H5, C6H5 2 time in between C double O, C double O. Okay, here bond dissociation will be taking place. Okay, one electron will be taken by this oxygen, one electron will be taken by this oxygen. Okay, and it is going to form 2C6H5 C double O. Okay, with electron. Okay, and then it is going to convert the free radical by losing of the CO2. Okay, so we'll be getting phenyl radical. Okay, this phenyl radical will be combining with the ethene. Okay, and it form monomer of ethene. Okay, with the free radical. Okay, then this was the chain initiation step. Okay, now we have to propagate this step. Okay, so it is called as a chain propagating step. Okay, so ethene, which we have taken with the electron, free radical we have to take it. Okay, one more molecule of ethene we have to take. Okay, now here bond dissociation will be taking place, and this will be combined with this free radical of ethene. Okay, and it is going to form the dimer. Okay, and this electron, okay, will go to the last number of the carbon. Okay, and the polymerization reaction will be taking place, and will be getting the polymer of it. Okay, which is having C6H5, CH2, CH2 n type, CH2 and CH2 with the electron. Okay, ऐसे ही दूसरी एक चेन लेंगे. ओके, और दोनों चेन एक दूसरे के साथ कंबाइन, यहाँ से पिंक कलर का जो कार्बन है वहां से कंबाइन हो जाएगी, एंड विल बी गेटिंग द चेन टर्मिनेटिंग स्टेप. ओके, देन सम इंपॉर्टेंट एडिशन पॉलीमर्स हम देखेंगे. ठीक है, इसमें पॉलीथीन, दो तरह के पॉलीथीन है. ठीक है, पर आज हम एक ही पॉलीथीन देखने वाले हैं. ठीक है, लो डेंसिटी पॉलीथीन विच इज कॉल्ड LDP. ओके, तीन कंडीशन है यहाँ पे बच्चों हमें याद रखनी है. ओके, वन इज 1000 to 2000 एटमॉस्फेरिक प्रेशर, सेकंड इज टेम्परेचर दैट इज 350 केल्विन to 570 केल्विन टेम्परेचर. ओके, एंड द कैटालिस्ट इज डाइऑक्सीजन और पेरोक्साइड इनिशिएटर. ओके, ये तीन कंडीशन याद रखनी है हमें. Then LDP obtained through the free radical addition, that is H atom abstraction. Okay, has highly branched structure. Low density polythene is chemically inert. Okay, and tough but flexible and poor conductor of electricity. That's why it is used in the insulation of electricity carrying wires and manufacture of the squeeze bottles, toys and the flexible pipes. Okay, so we'll be keeping till here. Okay, आज हम यहाँ तक रखेंगे. ठीक है.